Hi, I'm Gordon from Qdrive, a division of Chart Industries. Today I want to give you a little demonstration of one of our cryocoolers being used in a liquefaction application. That is, we'll be turning a gas to a liquid by bringing that gas down below its boiling temperature. To do that, we're going to be using our 2S102K cryocooler. It has the ability of producing about 6 to 8 watts of cooling at 77 degree Kelvin. And for a gas, we'll be using argon. Argon requires a temperature of 87 degrees Kelvin or below to turn to a liquid. Qdrive manufactures acoustic Stirling cryocoolers. We have a pressure wave generator which creates acoustic power in a helium stream which is fed down to a Stirling cold head. In the cold head, it's basically expanded to remove the heat from the area that you're looking to cool. In this demonstration, the argon will be fed up through a tube into a glass dewar. We're using a glass dewar so that you can see the condensation actually forming on the cold finger itself. As it forms, the droplets will fall to the bottom of the dewar and collect to be used for whatever reason. Now, let me pan in the camera a little bit so that you can get an idea of the components that the system is comprised of. As mentioned previously, the acoustic power that is required of our Stirling cryocoolers is generated within our pressure wave generator, or PWG. It consists of dual opposing linear reciprocating motors that are driving pistons within clearance seal cylinders. These have no moving parts in contact and therefore require no maintenance or no lubrication. The PV power that is in the helium is shuttled down the transfer line to the cold head itself. Heat is removed from this gas through a water-cooled heat exchanger, and then the gas is moved down to or through a regenerator to a cold finger where it is expanded. The cycle is then repeated. To control the cooling power of all of Qdrive's cryocoolers, you simply adjust the voltage supply to the PWG, which I'm doing here with a simple rheostat. For removal of the heat, I'm using a closed-loop cooling system, which you can see the cooling lines are going back to the cold head itself. Now, let me show you how to start up a Qdrive cryocooler. The first and most important item is cooling water. As mentioned earlier, we have a closed-loop cooling system providing water flow to our heat exchanger. I'm simply going to turn on that cooling loop. Once established water flow, you can simply turn the voltage onto the pressure wave generator. The system is now up and running. It's as simple as that. I'll come back over and you can see here we're monitoring the cold finger temperature, and you can see it's starting to decrease. It's relatively warm now because we're starting it up from room temperature, but you can see it's rapidly decreasing. I won't keep this video running for the whole time, but I will come back shortly after we've reached the cold head temperature of about 87 degree Kelvin, where we can start liquefaction. The system has now been running approximately 15 minutes. From the temperature gauge, you can see we're now at minus 181 degrees C, which converts to about 92 degrees Kelvin. Although argon condenses at 87 degree Kelvin, it has already started condensing because there is a difference between the temperature reading here and the actual cold head. If I focus in on the cold finger, you'll see the droplets forming and raining down into the bottom of the dewar. They can be collected there for further use. From this demonstration, I hope you have a better understanding of how a Qdrive cooler can be used to liquefy gases. Although this demonstration was using argon, which again required a temperature of 87 degree Kelvin to liquefy, we can also liquefy gases that require lower temperatures, such as nitrogen at 77 degree Kelvin, or gases that require higher temperatures, like oxygen at 90 degree Kelvin and methane at 112 degree Kelvin. Keep in mind that these cryocoolers can be used in a variety of different applications, such as cooling of semiconductor devices, high temperature superconducting cable cooling, and also infrared detectors and gamma ray and X-ray detectors. For more information about our systems, please contact us at qdrive.com or at the phone number listed below. Thanks for watching today. Have a good day.